Hi, I'm Firat Tekiner. I'm part of the product management team here at BigQuery, and I lead the data agents within BigQuery. And I'm here together with my colleague Adam Paternostro. Over to you, Adam.
Hello, my name is Adam Paternostro. I'm a data analytics specialist here at Google Cloud.
So, what we have been seeing and hearing from customers, we are really seeing that everyone is asking us to, simplify their data journeys. Everyone is really trying to unify and integrate in their data platform because there's a lot of, increased need for data, not just the structured data, but the multimodal data really coming and, being part of the data ecosystem. Traditionally, what we had is we had enterprise data, but once we bring that enterprise data and be together with the multimodal data that we have, things like the log files, the images and voices that we have as well, we can add more value to it. And all of this really requires AI assisted tools and agentic capabilities. We are seeing this a lot. Everyone really wants to do and use AI to increase their productivity, really do more, in their business and further opening up to their audiences as well. Real time is always, top of mind, but most importantly, the governance is required across the data estate for the ML and AI models. The evolution of data, management has really progressed. And I came up this slide 4 or 5 years ago, but it has been really evolving as we go through as well. One of the reasons that we are all talking and using LLMs these days and likes of Gemini is we really store a lot of information. We really need to make sense of a lot of information, right? And we cannot really keep up with that. And here you go, Gemini to the rescue, if you like, and LLMs to the rescue. They come and help us to do that. And we bring that into the environment. The reason for that we are storing a lot of data is if you look at how much a terabyte cost, like 2 decades ago, it had a lot of zeros in it. Nowadays, if I go into and look into the Google Cloud storage, a terabyte of data is, less than $10, right? So, and you see that there's a significant amount of, reduction. This allows us to store more data. Then what we have seen is the era of the data lake and data warehouse came, right? And the type of the data that we started storing has increased as well. Then we also started seeing moving away from just by SQL into more of the, using data science and different frameworks as a result. And because this really gave us more scalable and cost-effective ways of doing it. And then we gone into the lakehouse, right? So a few years ago, it gives you the unified data platform and it brings the different data formats and everything as well. And it gives the unified governance and, security. It really combines structured and unstructured data together, and it helps you to, build the ML models. But we are now moving more into a data and AI platform whereby it is AI native, it is multimodal, it is also agentic as well. You have the intelligence on multimodal data, right? And agentic AI uplifts the users, and it really brings all types of users together. We are seeing as a result of that the boundaries between different personas coming together, and we'll see how that really impacts. And when we come to the BigQuery side of things, this really comes in 3 ways for us that the agentic, unified, and flexible, right? And I'll be focusing on the agentic side of things. First of all, I would like to talk around what an agent is, right? Because there are a lot of descriptions of that, and I'll provide a little bit more detail in a minute. But agent is really a system is characterized by its ability to pursue a goal to complete tasks, just like human beings. You go to a coffee shop, and there are folks who works in the coffee shop, agents work in the coffee shop, right? They all pursue different goals. Someone takes the order from you. Someone works with the coffee, grinds the coffee, and then brews the coffee for you, right? and then maybe another person serves you the food. And unlike, tools, agents also showcase some proactive behavior. They can come and ask you, and they have some autonomy. And this, combination of the goal-oriented decision making and then the grow independence is really allows them to work in the capacity of human interactions. Let's get into a little bit more detail. When we talk about agents, right, the models comes in, we understand the intent of what that task is, right, what that problem needs to be solved. That can be brought us to a natural language, right? Someone can come and say what they're looking for, or agent can proactively can go and monitor. For example, a troubleshooting agent might go and monitor a system and see why the jobs have failed, look into that, and go and propose fixes, modifications into the work that happened. How do they do that, right? So they have some memory. They have a short-term memory that works within there, but they also have long-term memory. All the metadata that you have, all the context that they have, right? You can have your agent really to have information around what are the best practices to follow, what are the data models that they need to follow, what are the data types that works, what are the things that considered to be good data quality, right? What are the fields that are acceptable to be null or not? So this information comes to, and I'll talk a little bit more around how this will be managed later on as well. But as I said, they also use the APIs and functions and other databases and other agents as part of their tool stack as well. So the model comes, understands the intent, understands the problem, decomposes it to, what are the tasks needs to be done to solve this problem. It can be a single agent, it can be multiple agents doing that. It orchestrates that. All of the agents or agent works, towards a metric, towards a goal to solve that, iterates over it, and comes with the solution, right? And it is really similar to how ants works in real life, right? Ants, small creatures, right? They're very small. They always find the shortest route to the food source. They leave a chemical trail by the other ants, and they follow that. They do this all autonomously. But there are different type of ants in the ecosystem, right? There are ants that goes and finds the food. There are ants that they defend the nest, right? There are ants that looks after their larvae or the babies, right? So all of these work together, right? And they have different expertise. They learn from each other, and then they really look for the most efficient way of really, surviving. And then in terms of ants, they are very similar to the agents that we have. And then I already mentioned that the agent has, the model, the tools, and orchestration. But if I go a little bit further, right, then you can go and apply more tasks into that, right? So as you add more, you become more complex. If we take ETL or ELT, right? So what happens is you have teams of agents, right? You can have an ingestion agent, transformation agent, load agent, or you can have one agent that does all of these tasks, right? Within the same agent. As you become more specialized, as you start building the complexity, you'll have more agents doing that. At the beginning, you'll have one agent doing this as well. Okay. And the task that we are really looking to do, in this instance, is how we can focus on the data engineering task. And please, I want to clarify here. Data engineering task doesn't mean the data engineers, because there are others who these days carry out the data engineering task, like data analysts. They might want to do ETL. They can take some data, they cleanse it, enrich it, and load somewhere, right? Or it can be a data scientist who is building a model, and they might want to prepare some data to that. But usually these are manual and time intensive tasks. They are usually expensive. It takes a lot of time to get there. This slows experimentation and innovation, because if it takes weeks and months to manage a set of data pipelines, even if you have a simple regulatory change, right, it really takes the resources away from you. And then one of the reasons that I already mentioned this, right? There are a lot of disparate systems, particularly if you have more of the legacy, you'll find more of the systems. You might have lost the, know-how about the systems. You might have lost that, the knowledge that you have within the organization due to people leaving, due to people coming and doing and not documenting it, right? And it really becomes, challenging. So the data engineering agent really aims to help the data workers, right, to automate these time-consuming and toilsome tasks. If you are a data engineer, it allows them to really create the data sets and create the data models, right? Go and apply if there's a change to 1,000, pipelines or tables in one go. If you are a data analyst, it allows you to do, rather than you going and asking for a, the team, a central team, and wait for the data to be prepared, you can do it yourself. Or if you are a business user, you can access the data from various sources and enrich them, and then without needing the data engineering skills, right? You see that it really applies for variety of data workers. And how does it work, right? And how it comes together. The agent has number of inputs. The input can be supplied by the users. It can be just some questions to it. It will operate in interactive mode. It will operate in bulk mode, right? So what you can do is you can give one by one instructions, or you can take as a contract. You can write all the description and you can give it to the agent as one. Or you might even come and say that this is the code that I have been solving this task. I want to apply here, or these are my golden queries. Then, in addition, agent has access to some technical and business metadata. It can be your catalog entries, for example. It can be the curated data that it gives context to that. You might have a table which might be called XYZ123, and that might be your product table. Someone knows it somewhere in the organization, and they might have gone and annotated it, and it is in your metadata environment. The agent can go and disambiguate that, and if you go and say that I want to look into the products, it will come and do that for you, right? Rather than you needing to know that. And all of this information really helps it to make decision better. It can go and profile things for you. It can go and discover things for you as well, right? And it can give you the outputs that you are looking for. What it gives you is it gives you the code. In our case, it gives you SQL X code. It gives you metadata. It can go and write all the metadata as well. Metadata is very important. But as human beings, right, usually your primary task is to create something, and then your secondary task is to go and write some descriptions about it or information about that. And unfortunately, because of that, many organizations really, in time, ignores this or don't have time to do that because there are other priorities comes in, or there's a third party comes in, does something, they move away, and then there is no documentation, or documentation goes away as well. Okay, so an agent can go and create and modify metadata as well, and it can give you suggestion. It can go and say that, hey, I realize that this is the time format that your organization have been using, but you are using this in here. Is that intentional? Or the currency that you are doing is that, and then this data came in this currency, or the metadata tells me it comes in this currency. Do you want me to apply a currency conversion? The agent will become intelligent in time to be able to do that, and you should be able to do things in bulk as well. To summarize a little bit, agents will be useful. The data engineering agents will be useful to analysts because it will allow them to data wrangle and do the data engineering tasks. It is also going to be useful for data engineers, right? Because it will simplify how they deal with large amounts of stuff. It will also do proactive things like troubleshooting. And generally for data workers and data practitioners, it will really shorten the software development life cycle. It will simplify things for them. It will really release them to focus on the core business, and the organizations will really can reduce the cost of this by automating some of the tailsome tasks as well. Okay. It is really important that where the agent gets its intelligence. I already, alluded into a little bit, but I want to expand that, right? So agent has some base knowledge. It knows what a data format is, what are the SQL syntaxes and such, and common practices. You can come and complement this. You can give agent instructions, and you bring your domain knowledge to that, right? So what are your industry standards? What are the common data formats that you have as well? Agent will have some idea around that, but and by looking into everything that you are doing, but you can complement that. Also, there's the organizational and project context, right? These are my naming conventions. These are my security policies. These are my best practices. These are my golden queries that I'm using. That agent goes and refers it. It brings some standardization to it as well. And there's also pipeline specific context that it uses, right? The schemas, transformations, dependencies, it can go and look into the metadata and lineage and stuff for you as well, right? From the the catalog. The four capabilities that we initially focus on is how you can create a pipeline, a new one, rather you create one or multiple, how you can modify an existing pipeline, right? You can go and update the transformations or bring a new data source to it. How you can diagnose and do a root cause analysis and fix challenges that might happen in one, and how you can do this in bulk as well, that automate the creation of that. And this is where it really gets, as I call it, from assistive to more agentic, right? Because our agent then starts orchestrating things itself. It starts calling things itself as well. And I'll, talk around that a little bit once Adam does the demos as well. So to recap, we are really looking with the data engineering agents, right, to carry out the data engineering tasks. These days, we see a huge spectrum of data engineering task execution. Some organizations, data analysts do 70 to 80% of the data engineering tasks, right? Some organizations, they follow strict rules, right? The data engineers do all of that. Usually you see a span of that, and it goes to 8 to 20%, depending on the organization that you are. And then you also have the DBAs and the data scientists who comes and deals with that, and we are seeing more and more on that. But I think I have spoken enough. I would like to hand over to Adam, who can really show you how this works in real life a bit as well.
So today I'd like to talk about how we're going to use the BigQuery data engineering agent in an example where we're at a hotel and we're trying to analyze competitor prices. So we're going to receive the prices inside a CSV file that also has divisions in it for room amenities. We're going to use the data engineering agent to talk with natural language to cleanse this data. The resulting data will end up in a BigQuery table. We're then going to create vector embeddings. The embeddings will help us match similar terms. So for instance, not everyone might call a balcony a balcony. So we'll use the embeddings to help normalize the different terms used by different hotels. Then we'll also take BigQuery Gemini. So directly within BigQuery, we're going to call Gemini to do an analysis on this. And we're going to use our transactional data, which is stored in AlloyDB, to figure out how we should adjust our pricing. So I'll go ahead and jump into the notebook. So I'm within BigQuery Studio, and I have my notebook open here. And this is what we'll work through using the data engineering agent. The first cell here is simply the architecture, which we just reviewed. And then we have raw, unprocessed competitor pricing data. So I'm going to bring that file open so we can see what it looks like. Let me open that up. And we can use the data agent to ingest this data directly from storage. But in this example, I wanted to preview the data so I could show you the various pieces that we'll be cleansing. So everything is currently a string data type. And if we go to preview, you can see our dates have incorrect dates. We have hotel names that are capitalization is not standard. Phone numbers with different formats, some room types, some bed types that we can standardize. We also have our room features that are pipe delimited here, and we have our square feet and price. So we'd like to take this data and ingest it into a BigQuery table that's cleansed with the proper cleansing applied, as well as the proper data types. So my first step here is I have 4 prompts that I'll work through. And the first prompt here is I want to talk about the competitor pricing data set, and I want to make the hotel room type, bed type lowercase, and the first letter of each case of each word in uppercase. So let's go ahead and copy that prompt and create a pipeline. So I go to the pipeline. I need to pick a service account. So this is the account that this pipeline will run as, and I'll close that and we'll get started. So inside here where we have our canvas, and I can click on the agent, and this is where I can start asking the agent questions. So let me paste that prompt in there and go ahead and click go. Now it's going to read our prompt. It's going to take a look at the BigQuery metadata it knows about, and it's going to show its thought process, and then it's going to start building our pipeline. So as it goes through reading that and understanding each of the things we want done, it has successfully created the first step of our pipeline. So let's take a look at our second prompt. So now we want to clean up the phone number, which had all types of dashes and different formatting applied. So we'll paste that in there. It's now going to update the pipeline. So you can use the agent for either creating a brand new pipeline, or you can actually update an existing pipeline. So we're basically updating a pipeline at this point, and let's go ahead and went ahead and applied that. Now let's change our dates. We want to make sure our dates are correct BigQuery dates. So when we look at the table, we want to be able to operate on this with date as a date format. So we could do date functions on that, and it's a proper data type. So it's going to replace the forward slashes with a dash and update the pipeline. And now the room size, since I'm going to do math, I'll put the room size and the amount for the room as long as the date as those data types. So the date was just cleansed, but this was actually typecasted into the date format. And I'll show you the result of that. So it just takes a second for it to read your prompt, look at the data. It's going to insert the steps, and then we'll have our pipeline built for us. Okay, so it's inserting and it's done. So let's just take a look at what it built. So if I click on the pricing tab here, that's the destination table that we're going to put it in, and I can look at the code. You can see this is in, it has pluses here because what happened is when the agent started running, it started basically, you could think of it as a get diff, so it knows source control, and it's telling us what it has added to the existing pipeline. So if we were to apply these changes and do more changes, it would show us the difference between our existing pipeline and what it has done. So here you can see it's doing the initial capitalization, it's fixing up our phone numbers, it's replacing our slashes, and it's doing our typecasting for us. You can also click edit and see this within data preparation. So there's another view for you to take a look at this to see what it was done in an interactive view. So when you're done with that, you can actually click on run and it will execute it. It only takes about a minute to run, but I've already run it right before the demo. So we'll take a look at the table that I've generated. So let's look at the pricing one table. We'll open this in a new tab. And you can see the first thing here is we have a date data type. We have our string still. We have our integer and big numeric. And if we preview this data, you can see the dates look clean. Our hotel names look good. Our phone number has been normalized. We have our room types are still there. Our room features are inside here. And we have our square feet and pricing. So it looks like everything's great. So you can actually now schedule that pipeline to be a recurring task. And then the next step, I create a primary key. So we're going to put it into a pricing table. So I just have a primary key if I wanted to do some joins on that. The agents can also do joins. So I'm not demonstrating that yet, but you can actually bring in other tables and join to your table as part of your prompt. So we looked at the clean data. So we just looked at that. So we'll scroll down and let's take a look at creating our embeddings. So within BigQuery, we can create connections over to Vertex. So I have a Vertex AI connection. And in this, we want to use a Gemini Flash model. And we also want to use our text embedding 005 model. So these models are easily accessible, even though they're in Vertex AI. We simply create a connection and we'll be able to use these directly in our SQL statements. So let's take a look at what the embeddings do. So I'm going to run this statement, and this is going to create a new table. It already exists, but it's going to split our room features that had a pipe in it, and it's going to split them. And then we're going to unnest it because it created an array. And then we're actually going to use this to generate embeddings. So we'll get a list for every room, the feature, and then we're going to call our text embedding model on it with a semantic similarity. So this is going to let us search for things that are similar. So for instance, when we come down here, we're going to search for the word balcony, and we're going to do a vector search here. So we create the embeddings first, and then we're going to search for the word balcony. We have to embed that using the same model, and then we're using this semantic task type again, and it's going to run and find everything that's like a balcony. So for instance, balcony and balconies has a distance of 0, so it's very close, so it's the same word. So you'll see the distance increase. So some of the competitor data is using the word terrace, veranda, and porch. So we want to treat all them as quote-unquote balconies in our analysis. And you also see this for things like hair drying. It will come up with semantic matches here. You see hair dryer or blow dryer with and without a dash. So it's really powerful and easy to do this, because doing different queries to say if it's hair dryer with or without a dash, or a blow dryer with or without a dash, there's too many permutations to code up. So we can vector embed it, and now we know our room features. So let's go ahead and compute our competitor pricing. So we're going to do a query here where we're going to search for the word balcony, and then we're going to do the same thing and say when it's not in a balcony, and we're going to union them together. So we're going to search for all the rooms that have a feature that has a balcony or something similar to a balcony, and we're going to take all the rooms that do not have a balcony. So if you look at the no balconies, we have 412 average square feet, and a balcony is slightly larger, which is normal, and then we have a price, and balconies are usually more money, so we have a price as well. So how do we take this data and use it in our transactional system? So I'm going to jump over to our transactional system, and we'll take a look at those queries. So I've switched tabs, and I'm now in AlloyDB, which is our transactional system. So we also have vector embeddings over in AlloyDB, and we're using the same 005 model. So I can actually share my data between our BigQuery system and our transactional system, and they have those embeddings. And since we have the same model, we can actually do work across those two systems using the similar vector embeddings. So for here, we search for the word terrace, and you can see balcony comes up very close, and also ocean view, but that's not quite a balcony. So we're going to use the term balcony inside our transactional system, and then we're going to do a query on that to see our room prices. So let's run this query. This is very similar to the one we just did in BigQuery, where we have our average square feet and our average price. So our no balcony is 420, and our balcony is slightly larger, and then our prices are 257 and 286. So again, we have our transactional data. We can actually do vector searches across that since they use the same model, and we're going to take this data and then further do our analysis between what we're charging for balconies and what the competition is charging for balconies. So I'm back in my notebook. We went over to AlloyDB and we ran these queries so we could see how they worked. But how do I access this data directly from BigQuery? So BigQuery lets us do an external federated query, and we took these same exact queries we ran in AlloyDB, and now it's embedded in a SQL statement within BigQuery. So I'm going to run our internal pricing here and using AlloyDB, and then we're going to run our competitor pricing that we brought in with the data engineering agent. So we have our results here, and you can see we have AlloyDB, balcony, no balcony, and BigQuery, balcony, and no balcony. So we're going to use this data to figure out are our prices competitive for balconies. Now, what I'm going to do is show you a visual. So I hard-coded the data here, same data as above. We could put that query above, but it would take up a lot of space. So I put the data in here, and we did an analysis, and you can see visually that we're undercharging. So we know that our hotel charges less for balconies, so we should adjust our pricing. But how would we do that if we don't have a visual? So I had to go ahead and create a graph, but what if we're going to automate this process? And that's where we're going to use Gemini to make the decision for us. So here's our prompt. I'm going to have a prompt here that has what I'm doing, which is I'm comparing competitor pricing, and then I need you to generate an explanation of what we should recommend to management. And this is our context, which is the same data as above that we got above, and I'm going to encode it into JSON. So our first step here is to create a prompt. So we have our prompt, And I left this place here for our vector embeddings. So our embeddings to search, which uses those vector embeddings. So my first thing to do is do our external query and get that from AlloyDB. And then I bring in our data from BigQuery using our vector embeddings. And then I'm going to create a JSON structure. So that gives us a nice clean set of data that we can inject into our prompt that's replaced right here. So we've seen that before, but what's new in this query is we're going to call generate text, and we're going to simply replace that string with the data that we have from AlloyDB and from BigQuery. So let's go ahead and run this. And this will execute the Gemini 2.0 Flash model, so you can try different models and also update the prompt to see how the results are. So it gives us a recommendation. So it gives us, we should consider increasing our pricing for our balconies. Does that sound reasonable? And then there's a long explanation down here saying the amount of money that we should increase it by about $22. So we got the results we wanted. But one last step I like to do is, how do we know that Gemini or your LLM didn't hallucinate in general? So I'm going to take this entire prompt and the result and now pass it back to Gemini. So I'm going to ask Gemini to respond back with a true or false and a reason to explain its reasoning. I'm going to give it our original prompt, and I'm going to give it the response that it generated above. So we're using an LLM to check an LLM, and then I'm going to call a slightly different function down here called AI generate table. So above we got back text, but what if we were stringing our pipeline along and we needed to do one step and then do another step? Parsing text isn't super reliable, especially even prompting your LLM to generate proper JSON, but we can call generate table, which will return back a response Boolean and a reasoning string. So this means we'll get back known columns for our data. So this will verify and say true that, yes, updating the price for $22 is accurate. So if we came up here and maybe we said decrease the price, when we go ahead and run this, we would try to trick the prompt, and it replies back false, that it wasn't an accurate statement. So if we basically get back true from this, we know we can trust the accuracy of what our analysis. So I'm now going to turn it back over to Farad. Thank you.
Thank you, Adam, for showing the demos. So effectively, we have 4 use cases, as we mentioned. You can create a new pipeline. That pipeline can take data from cloud storage and load into BigQuery table, and it can apply, some transformations. It can infer the schema and everything as well. You can also modify a pipeline. A data engineer needs to modify a pipeline to add a new data source or new transformation. You can go and do that, right? And you can, agent can help you to streamline this process. This is really more on the assistive side. The agent is coming and helping, and then you can see the code that is generating, and you accept it, and it goes into your environment. The next stage of that is, imagine that you run some data pipelines, and whilst you run these data pipelines, right, there are a few errors that happens. Agent can go and look into what those errors are, do the root cause analysis, say that this is the pattern that I'm seeing, this is the fix that I'm doing, as you can see on the screen, right? You can come and take that fix for one, but then agent can come back and say that the same fix can apply to all the other, jobs that fail. Maybe something, changing downstream or the upstream that it caused that, failure, right? You can go and review all of these at the same time. You can go and apply all of this at the same time. And this really becomes more agentic. Agent becomes more autonomous, right? Because it can go and do things that otherwise a data engineer or a DBA would go and monitor the environment, try to see what all of these failures are by, going to all of the, the error logs, trying to understand the challenges. Well, agent can do that, analyze root cause as well, and also propose a fix and fixes things as well. The other side of that is that the data engineers tend to create a lot of pipelines and modify a lot of pipelines in one go. You might get, I have 100 files that arrives or 100 tables that arrives from a system into this Google Cloud storage bucket. I have these instructions that I want to go and apply to every single one of them. What I'm showing in the screen here is you can go and analyze and get that metadata, the metadata that the agent has access to, whether you supplied or whether it has through the metadata that you have in the system, right? And you supply via the, some commands or some code or some, agent instructions, right? You can go and grammatically, do this, apply this. We are showing, through a CLI here, you can do it through a UI as well, right? So you can go and say that I'm going to pick and I'll apply the same thing on all the 100, pipelines that I have. It really goes and works really well with the, the ecosystem that you have. It can go and, integrate with Git to check out things based on your, from the repository. It can check out things based on your guidance. It can go and, apply the fixes and check things back into your repository. And you can go and review this code because the same code, the SQLX code that it is generating at the end of the day. So, you can go and use from multiple surfaces that we provide to here as well. You see that this becomes a lot more agentic, right? So it becomes a lot more autonomous. As the autonomy goes up, the agency goes up as well. It also starts serving, more technical use cases as well. And then there will be, multiple agents that are focusing on different tasks. Again, to repeat, right? So what we mean by that is an agent focused on solving a task, solving a problem. It is not really looking to replace a person to do that, right? It is really there to uplift the users, right? So we are all going to become more productive. We are all going to do a little bit more and more in the time that we have as well. And we'll be able to do other things as well, right? And then we'll see more specialized agents that are coming through, right? The data engineering might come and take the data, right? Cleanse it, you create the pipeline. A data science agent might come and take that, input as the model and go and run a model as well. Again, you don't need to have the, all the skills to have that. And they'll share some toolbox, some tools and capabilities. They'll share some metadata in the process. And to recap, BigQuery data engineering agents really focuses on automating the toil and assisting the data workers, right? There's lots of manual coding happening. There's constant updates happening. It is hard to find, and discover the data. They're, cryptic names usually. There's limited access to the specialized use case as well. You find certain teams becoming, bottleneck, right? The agents and data engineering agents makes it really much easier, right? It automates the creation and updates as we have shown to you, myself and Adam. You can manage hundreds of pipelines at once, and you can, as I mentioned, you can maintain the standard doing that, right? So because you can tell it to follow certain rules all the time, and you can have the instant metadata and quality directly there, right? You can read more, you can follow these QR codes on the links here, right? We have written about that, and watch the space, we'll be doing a lot more. But bear in mind, right? Agents are really here to help you, right? To make things easier for you. With that, thank you very much. Thanks for listening. And as I said, if you are interested, please follow these links and read more about it and register your interest. Thank you.